Right. So in this talk, I'm just going to talk about PyrrhoDBMS management system, where I'm focusing on doing an implementation of GQL. Not sure if there's a feedback system. Yep. The microphone's on though. Okay, just to explain anyway, that Pyrrho is not a product. It's not like, you know, some of these systems that where people are creating things.
Your laptops, this should go down. Yeah.
Okay, is that better?
Yeah.
Right. It's not a product. It's a research project, and I've been working on it for quite a long time, since the early 2000s. Of course, in the early 2000s, we didn't have GQL, we had SQL, and but I've used Pyrrho as a way of investigating different database technologies, generally as alternatives to the standard or textbook implementations of relational databases as it has been up till now. So that it's open source. Everything with Pyrrho is open source, which means that anyone can use any of the code or any of the ideas or incorporate them into any product that they want for no charge. But I would like people to mention that they got the ideas from me if they did. So it early on, it got an allocated port from IANA, port 5433, which means it's an official standard port on TCP, and it's got an open protocol. So the idea is it runs as a database server with an ordinary account. It's not a system for a system service, and communicates by means of requests coming over TCP from a client. So it's directly implements commands in SQL or GQL and returns the results. And it targets GQL now as an extension of its SQL implementation. And at the moment, the last count, it's planning to support more than half of the many hundreds of features that there are in GQL. So I'd hasten to say that of the 228 GQL features, some of them are alternatives. So I really don't think it's feasible or possible to implement all of them, but I think I've selected a good large number. My implementation of GQL anticipates some evolution of the GQL standard, which I might manage to mention a little bit later on in this talk. To be clear, Pyrrho is ACID. It uses transactions that are atomic, consistent, isolated, and durable. And it always uses serializable transactions. You can't do any cheating like repeatable read or anything like that. Everything is serializable. And since 2018, it uses shareable data structures throughout, which is, I recommend as being the only good way of implementing concurrency. So-called pessimistic concurrency, where everything is done by using locking, really doesn't work, and it certainly doesn't work over the web. So that, but using shareable data structures where you can freely share things with other people, and they cannot change them. They can if they make a change. Akon's nodding. You agree with this approach. So anyway, like strings. So databases should be like strings. If you make a change, you get a new database, like a new string. And it does a few mad things. It has the full SQL security model, including US Department of Defense Orange Book protocol for mandatory access control. It's an option. You don't have to do it if you don't want to. And but it's culture and hardware neutral and uses universal time. And the current state is available on GitHub. this is the address on GitHub, Malcolm Crowe shareable data structures. There's a folder in there called Pyrrho version 7 alpha. It's always alpha, well, maybe eventually it'll become beta or even released, but at the moment it's alpha code because every week or so there's a new version. It targets .NET 8, and I develop it using Visual Studio 2022 Community Edition, which is free to use for independent programmers like me. And the binaries will work on Windows, Linux, and Mac OS, so you're not limited to using Windows machines. And it includes the server. It includes a set of client utilities. It's got user manuals and source introduction to the source code, that sort of thing. And the GitHub repository includes a book that I published about it in 2015. It includes the version of the LDBC financial benchmark. And so I'll throw some of that up in a moment. And the famous yacht club example from Nadim Francis in his researcher's guide to GQL. So there's let's see, I think I've got the wrong window selected, just a moment. That's what I want to do. Right, so in changing from SQL to GQL, which just has happened as far as Pyrrho is concerned during the summer, the idea is that the reserved words in SQL are no longer protected in my implementation. The SQL syntax will still work provided that the reserved words are respected. If you change a word like table or procedure to mean something else, then of course you won't have that syntax. But provided you all of the GQL reserved words are reserved, and the primitive types in GQL are compliant or implemented. But the primitive types in Pyrrho were always different from SQLs anyway, so that it probably, that was no cost, done at no cost. So the GQL syntax has been added, and the graph element types are subtypes of SQL user-defined types. Added support's been made for label sets and multiple inheritance, and the way that GQL does edges involves a direct reference to what I call the position. To explain, in Pyrrho, the only representation of a database on disk is the transaction log. So the whole transaction log is on disk, and nothing else is on disk. Everything else is in memory. So that any database object has a unique defining position, namely the place in the transaction log where it was defined. Okay, so that position is unique, and it's a kind of object identity. So I view records as being the source of database of data. Every data has got a unique identifier, namely the place where it occurs in the transaction log. And that's used to label things like nodes and edges. So that means that we don't need to use SQL-style foreign keys for graph structure. We get it free from this kind of object identity. And Pyrrho goes a little bit further than GQL version 1. It allows, of course, SQL language for things like methods. SQL is programming language for things like methods. It has extra primitive types have come from the GQL research community, which aren't in the specification yet, things like set and list and so on. And it's got multiple inheritance. Records can have multiple types, like some of the research papers. And graph data can be shared in other graphs. You remember in the yacht club example, you had two overlapping graphs for social and fraud, and that's implemented inside Pyrrho. Importantly, the match statement, the binding that goes on in match can bind to values, to property values, not just nodes and edges. So you can bind down to the level of properties. And metadata is implemented in PyrrhO, which gives other ways to specify constraints like multiplicity, cardinality, and so on. I'm excited by the idea of using graph schema as a graph, and that's something that we're working with, that Alistair's got a group looking at in the GQL community, and I think that's important. Also, I think that another thing that's important is the idea of remote access using HTTP to graphs, so that it's basically using view-mediated remote access. So it's there, it works. I hope I'm probably running over time already, Alistair, so stop me just if I but all right, okay. Just to say, in use, it's a little bit more relaxed than it should be. It's sort of is fairly tolerant of people playing fast and loose with syntax, provided we can work out what the user means. The implementation is very compact, very lightweight. The server is less than 2 megabytes in the binary of the server is less than 2 megabytes, and on starting up it uses only 4K or something, and sorry, 4 megabytes, and the smallest database you can have is 5 bytes. It's an empty database, of course. There is an HTTP server inside PyrrhO that can draw graphs. So there's a demo coming up. It's based on the workloads in the LDBC financial benchmark with the SF1 snapshot. Right, so I'll share a different window so we can see what's going on. Let me try and find the right thing to share. This is an extract from my version of the GQL sorry, the financial benchmark specification. Shupang showed you this example from the complex read 8 example, and it's quite interesting. As he was describing, it highlights a number of different aspects of the kind of thing that the financial benchmark targets. Things like the path pattern matching and so on. So that if we look down here at my implementation of this in my version of GQL, my syntax, we create there's create procedure, which looks a bit like an SQL procedure, except that we've got things like truncation limits and truncation orders as strings. That's something that I tried to implement following the financial specification. You can see here some of this matching down to the level. Here, this is an undefined, an unbound variable, AMT, which will be bound to the value of amount in that particular node, and so on. The business about the ordering of create times is done in this kind of way, that this is in the middle of a path pattern matching, quantified path pattern matching expression. And so cardinality, create time is the create time value from the node that's being considered to add to the path. And the bindings are all arrays of the ones that have been bound already. So this says compare the current create time, that's create time X, So create time X is the current create times compared with the previous ones, that X cardinality up to cardinality -2 is the previous ones. And if that's the condition on the create times being in the right order. So so truncation is being implemented, as you can see, and this kind of linearity. We've got an OR here, a vertical bar, and we've got various other features that are highlighted by complex read 8. Well, okay. As I said, all of this is under development as far as PyrrHO is concerned, so that means that some things are only just becoming available now. So let's look at this. Is starting up the server is just starting up the server as in an ordinary account. So that's the server being started up, and let's try running the database. No, let's not have that one. Let's have this one. Right. Okay, and we'll get an example, complex read 8. This is in a file that Shipeng sent me. This is an example. An example. No, I want. Just wanted to select that. So let's send that to the server and see what kind of results we get. And we get hundreds of replies quite quickly. Okay, so those are the things that have been ordered. The complex read returns the distance from a loan, a destination account, and a figure that computes the amount that account has received of the amount of the loan. So it's quite a complicated thing, but it's got hundreds of rows in the results that you can see. Right, I've compared that with the file that the answers that Shipeng provided, and I don't find things matching terribly well. So I can look into this and find out what's actually going on. And so I could take, for example, get the first 5 rows by getting some more details, by sending the match statement directly to the server. And in this case, let's make that a little bit easier to read. Whoops. In this case, we can see the amounts that have been matched and the dates. It's important to check that the dates are in order. Okay, that's one of the requests, requirements in the complex read thing. So we can verify the actual things that are being included in the match. Here we don't see the actual tracing of the edges. So let's take a look. Sorry, that's a different one. Take a look at the actual edges that are being matched with a slightly different query. And here I've requested the actual IDs. You can see there it's returning A1 and A2. A1 is the id of one of the ends of the pattern of the pattern, and A2 is the id of the other end of the pattern. So we're seeing the ordering of the starting nodes in the pattern and the ending nodes of the pattern. So this is the node that's being reported as the destination account. And of course, this one will correspond to this one will correspond to this one. That makes sense. And so we can verify that the correct nodes, correct data is being returned from the database and compare it with the answers that we're getting. And in this way, I'm able to validate the answers that I'm getting, even if they don't quite match the ones that were in the file that Shipeng sent me. Shipeng's listening, I hope, and will give me some interaction with this, I'm sure, after my talk. A couple of other things, though, that where I was getting I did get the same results as Shipeng. So things like simple read and so on worked. Here's one that didn't work. From his file, he had this query. And I get a whole lot of edges. This is where simple read 6 is looking for related accounts. Let me find where that is. Simple read 6. I'm not really sure I've got time to go into this just now, but suffice it to say that here I'm getting results, and in the file Shipeng had an empty result for that particular query. So I hope that in the process of the revision of the financial benchmark that's going on, we can have a dialogue and see what other check that I'm understanding things correctly. Some of the queries that are in the file that was sent to me take much too long, and I'm going to learn from that as well, because there are ways of improving the amount of searching that takes place, the way of rewriting the match statement in order to reduce the amount of useless searching that takes place. So it's all fairly new to me. So and for me, it's extremely exciting to be able to see this implementation taking shape. I think I'd better stop. Are there any questions?